Good morning all. This is question 7 on homework number 2. To start off, make sure that you are able to balance the equation. This is antimony oxide reacting with carbon to produce antimony and carbon monoxide. Our first step is to go ahead and list out each one of the elements and identify how many of each we have. For antimony, on the reactant side, we have 2. The oxygens, we have 3. Carbons, we have 1. We get those numbers due to the subscripts. For antimony, we have 1 on the product side, 1 on the carbon side, and 1 on the oxygen side. The first thing we always balance when balancing chemical equations are the metals. So let's go ahead and look at antimony, Sb. Currently on the left side, we have 2. On the right side, we only have 1. So what number would we want to multiply by? 2. And that 2 represents our coefficient. Then let's go ahead and go down to carbon and oxygen. Also, if you notice, I accidentally did something. I put the elements in the wrong order. I apologize. Typically, when you're balancing chemical equations, you want to write the elements in the order in which they appear on both sides, in that order. So I put antimony, oxygen, carbon. I'll do the same on the right side as well. That just keeps our brain thinking. What do we need to multiply oxygen by on the reactant side to make equal to 3? We multiply by 3. That 3 represents our coefficient. And that 3 is not just going to multiply oxygen, it is also going to multiply the carbon. So we also have to multiply the carbon by 3. Now to make sure that the carbon is balanced on the reactant side, we have to multiply that by 3. And that 3 represents our coefficient. So our molar ratio is going to be 1 to 3 to 2 to 3. 1, 3, 2, 3. That was the first step. Now to do the actual problem. Number 7 says determine how many liters of carbon monoxide are produced from 0.465 grams of antimony trioxide at standard temperature and pressure. So let's go ahead and write our railroad. What goes in the first one always? What we are given. And that's probably going to be what we have numbers for. So what we're given is 0.465 grams of antimony trioxide, Sb2O3. Then, what are we wanting to turn that into? If you remember your mole diagram, where we have the 2 hearts, we're currently starting at mass of substance A. The mass of substance A. And we're wanting to turn it into liters of substance B. Liters of substance B. And substance A, we're referring to antimony trioxide, that's what we're given. Substance B is referring to carbon monoxide, what we want. So we're going to start at mass. We have to convert mass into what first? Moles. Then we'll convert moles into moles. And then we'll convert moles into liters. So this represents our game plan, what we're going to be doing. Note, when determining what goes on the bottom or the top, what does it have to be? It has to be the unit that is diagonal. So this is going to go down here, the grams of antimony trioxide. Remember our game plan, we're going from mass into moles first, so we're going to turn grams into moles of antimony trioxide. And by the way, is it important to include our actual chemical? Yes. Then we're going to convert moles into what? Moles. How do we know what goes on the bottom of our railroad? Has to be diagonal. Has to be the same thing diagonal. We're converting from moles of antimony trioxide into moles of carbon monoxide. So we've gone from grams to moles, from moles to moles. Now we have to do what? Moles into liters. What goes in the bottom? The same unit, moles of carbon monoxide. And we're turning moles into liters of carbon monoxide. All right, let's go ahead and fill out these numbers. If we look at this first railroad, what number always goes beside 1 in a molar conversion? Oh, excuse me. What number always goes beside moles in a molar conversion? 1. How do we know the number of grams are equal to 1 mole of antimony trioxide? We have to solve for its molar mass. Now, the molar mass of antimony is 121.76. Then the molar mass of oxygen is 16.00. That's an O. And that's a capital S. How many antimonies do we have? We have 2. How many oxygens? We have 3. 121.76 times 2 is 243.52. And then 16 times 3 is 48. Add those two numbers together, and it should give you 291.52. Again, on the test next Friday, you should be able to solve anything's molar mass with ease. Should not be a difficult thing. So 291.52. If you're still struggling to solve molar mass, please do watch those videos. Then, we have our molar mass. We got those numbers good. How do we know the numbers that we put before the moles in a mole to mole conversion? Is it going to be 1? Not necessarily, right? In order to find the number that goes beside moles, we have to look at the coefficients of our balanced equation. Here's our balanced equation. So what is our coefficient for antimony trioxide? 1. What is our coefficient for carbon monoxide? 3. All right, good. Let's go to the next one. Here's our final conversion. When we're doing a mole to something conversion, what number always goes beside moles? Always 1. And how many liters are in 1 mole of anything? Is that a constant? Yes, it is. What is that constant? 22.4. Some of you on the test might have missed that and said 2.24 or 224. Make sure that you know 22.4. Okay, there we have our entire railroad set up. In order to put this into our calculator to solve it, we're going to multiply all these numbers across the numerator. So we're going to do 0.465 times 3 times 22.4. Now, if you wanted to do this all in one step in your calculator, you could open a big set of parentheses and then divide that by 291.52. That just represents the product of all the numbers on the bottom on our denominator. So let's go ahead and put that in our calculator. 0.465 times 3 times 22.4. That should have given you 31.248 divided by 291.52. That should give you 0.107189901 and so forth, right? Should I tell you how many decimal places to round to? Well, hopefully, what should you use as your basis? You should use sig figs when you're given. How many sig figs are we given? How many do we start with? Well, reminder, is this 0 significant? No, zeros were not born to lead. That 0 is not significant. So note, we have 1 sig fig, 2 sig figs, 3 sig figs. 4 is significant, 6 is significant, 5 is significant. So we have 3 sig figs. We got 3 sig figs in our given. We should have 3 sig figs in our answer. Is this 0 significant? No, but we have to keep it to make sure we understand it is a decimal. So here's 1 sig fig, 2 sig figs. That 0 is significant because it's between 2 non-zero digits. And then 3 sig figs, and we'll round at 7. So our answer is 0.107. What do we need to include? Our units. Grams have canceled. Moles of antimony trioxide have canceled. Moles of carbon monoxide have canceled, leaving us only with liters of carbon monoxide, and if not be fancy, at standard temperature and pressure. And that is our final answer. Please message me if you have any questions. This is the answer to number 7 on homework number 2. Reminder test corrections. And both these homeworks are due at the start of class on Monday. We will review some things, and then we will take a quiz on Monday. May God bless you. Have a good weekend.